Hello dear learners, I'm Zinnah. I welcome you to the new topic, another topic today. Today's topic is intermolecular forces and molecules. These two words I'm using, basically these two are two terms. One is molecule, another is intermolecular. So these two words are very related because intermolecular must have been from molecules, and to understand intermolecular or intermolecular forces or many other properties of molecules, you first need to be clear about molecule. So this is the point, important point, because I even get some advanced learners getting mistakes with the term molecules. Suppose they make the mistake and they say sodium chloride is a molecule, but ionic compounds cannot be molecule, they are crystalline lattice. Why so? To understand this, you need to be clear about the definition of the molecule. What is a molecule? A molecule is defined as a group of atoms covalently bonded. So here again in this definition, two parts of the definition. One is this is a group of atoms. Another, the group of atoms are held together by covalent bonding. So when any substance follows these 2 points to conditions, then that can be called molecule. So I'm giving an example. Suppose water here, H2O, we write water is a molecule because this water consists of 3 atoms, 2 hydrogen atom and 1 oxygen atom. These 3 atoms are held together, they are bonded by covalent bond. So this is a molecule. But is sodium chloride a molecule? No, because sodium chloride is not a group of atoms. This is group of ions, sodium ion and chloride ions, and there are many ions that are together regularly held. And we basically call that ionic lattice. And to be clear about ionic lattice, you can watch our another video of ionic lattice. And today's topic is different. This is focusing on the molecule. So to be a molecule, a substance should have some group of atoms, and they must be held together by a covalent bond. Very simply, we can understand that not only water, many other substances also exist as molecules. Just to see whether the substance made of a metal and non-metal together or only non-metal. If you get any substance, suppose here ammonia, NH3, made of only non-metals. Here you get nitrogen and hydrogen, both are non-metals. So whenever you get this substance consists of both are non-metals or all of non-metals, then they are molecules. But if you get the substances which consist of metals and non-metals together, then they are not molecules, they basically are ions, and the ions are held together in the giant ionic lattice. So this is how you can understand. There you can get many examples. Ionic compounds are sodium chloride, calcium oxide, ammonium sulfate, calcium sulfate. There are many. And for molecules which are covalent substances, you get as water, carbon dioxide, ammonia, methane, nitrogen, hydrogen. These are all molecules, simple molecules, because in these molecules you do not get any metal. So they are all group of atoms, and they are held together by the covalent bonds. And here we get water bottle in my hand. There are many water, and when I say many water, what do I mean? There are many water molecules together in this bottle. So this gives a large volume of water. And how many molecules could be here? There are many, uncountable number of molecules here in this bottle. And if you get just one molecule, you get the 3 atoms together, which is 2 hydrogen atoms and 1 oxygen atoms. These 3 atoms are held together by covalent bond. So here we'll get the many molecules, and each of the molecules are a group of atoms covalently bonded. But how are the many molecules again held together? That is another question. For this question, you need to have the idea about intermolecular forces. Intermolecular means between molecules. So here are so many molecules, and many molecules are again held together. This is actually another type of bonding which we simply describe as intermolecular forces. A molecule attracts another molecule. So that we get a type of bonding we call intermolecular forces. So we can define intermolecular forces as the attractive force which holds the molecules together. It's called intermolecular forces. And intermolecular forces have many types. Just we are not going to explain the types, we're just using these intermolecular forces. Now let's compare intermolecular forces with covalent bond. Which one is stronger? Certainly intermolecular forces are much weaker than covalent bonds. I'm giving an example for this. If you get a small amount of water and heat to boil water, when water boils, the water gets separate, the molecules get separate, and this time you are breaking the intermolecular forces, not the covalent bond, because the heat given is enough to break the intermolecular forces, but this heat is not enough to break the covalent bonds. So whenever we heat and boil water, we get again water. In the gaseous phase, that the molecules are still water molecules, but the molecules are all separate. They are moving at random and they are separate. In the gaseous phase, the atoms are still held together within the molecule, but the molecules are separate because your heating has separated the molecules, not separated the atoms. So this means that covalent bonds are much stronger than intermolecular forces. And now you can also compare intermolecular forces with ionic bond. And when you heat an ionic substance, suppose sodium chloride, you need to break their ionic bonds, and that needs a very large amount of heat. Suppose sodium chloride needs above 800 degrees Celsius to be melted, and water needs only 0 degrees Celsius to melt on ice, and for boiling this needs only 100 degrees Celsius. For sodium chloride, that needs a very huge temperature, above 1600 degrees Celsius. So you can understand easily. Well, what happens when you melt or boil ionic compounds? In melting or boiling ionic compounds, you need to work against their ionic bonds, which is the electrostatic attraction between cations and anions. You need to first weaken the attraction to melt, and then again heat, much more heat to break the electrostatic attraction completely to boil the substance. And now you go for comparing intermolecular forces with the ionic attraction. You get the ionic attraction much more stronger than intermolecular forces. So we conclude that intermolecular forces are weakest type of bonding, weakest type of attractive forces compared to covalent bonds and compared to ionic bonds. And many other examples you can see. Suppose nitrogen gas, oxygen gas, carbon dioxide gas, they are already gas. Why are they gas? Because this is the property applicable there, because they consist of molecules, small molecules, and they're supposed to be together with very weak intermolecular forces. But when you heat with a very small temperature, then they get separate, they break the intermolecular forces, getting gas here. And when you get them already gas, which means the room temperature have caused them to boil, and they are already gas because they have very low boiling points. And some substances are already liquid. Suppose hexane here. Hexane is a covalent substance, consists of molecules, and when you heat with a low temperature, hexane can boil because that is their weak intermolecular forces. But the intermolecular forces of different substances not same. This is generally weak force, but this weak is not same for different substances. Suppose you get an example, bromine consists of molecules and which is liquid at room temperature, and get another substance which is iodine. Iodine is solid. So why this is solid and another is bromine is liquid here? Both are consisting of molecules, and molecules means they are having weak intermolecular forces, but the weak intermolecular forces not same for both the substances. In iodine, you get the intermolecular forces stronger than the intermolecular forces in bromine, because iodine is bigger molecules compared to that of the bromine molecules. And here you get chlorine is another example. Chlorine is already gas because they're even tinier, smaller molecules. So that you get, when you get even bigger molecules, that will have greater, higher intermolecular forces and will have high melting and boiling points. But this is still generally that we say that intermolecular forces are much weaker compared to ionic bond or covalent bonds. Let's discuss another property of simple covalent substances, which is electrical conductivity. For a substance to be good conductor of electricity, the substance must have free electrons or mobile ions. Free electrons we get in metals, and mobile ions we get in ionic compounds when they are molten or dissolved in water. But normally simple covalent substances do not have any of them, no free electrons, no mobile ions, so they are not good conductor of electricity. So these are all about intermolecular forces and substances with the molecules, short small molecules, and their properties. So I think this is an easy thing to understand, and I hope this has made your concept of intermolecular forces and some of the properties of covalent substances very clear. So thank you very much. Thank you for watching the video.